Okay, this should be on then. Are we on YouTube? Yes, should be on. Yes, we are. Okay, I gotta make sure everything goes through. There we
I
go.
muted
Okay.
my tab.
That fucking echo. Okay, and now I've muted everything properly, I think. Is the audio fucked?
I can hear you here.
Okay,
Let me
cool.
check on the YouTube side. I'm going to mute this. And
Yeah,
then...
sounds good. Testing. The ship was the pride of the American side, what left fully loaded for Cleveland. Awesome, thank you. You are Dead Bug Engineering, Frank?
No, that's not me.
Yeah.
Audio sounds good on the other side.
Cool, okay, I don't know. Oh, okay, so the YouTube comments show up in the streaming backend. Awesome, okay. Okay, I think that is all the little social media bullshit I needed to do. Okay, cool. So let's start. So Frank, you've been trying out different editors recently, haven't you? You've been experimenting with Helix, right?
Yeah, just a little bit.
Cool.
I haven't gotten comfortable with Helix yet, so I crawl back to VS Code whenever I need to move faster. But I'm really excited about Helix, and I want to be able to do it. If anything, just for the surround gestures and stuff. Like, I want a modal editor to switch my quotes to backticks. Really easy.
Being able to just have like an easy key command to say, this is the text I have. Change the surrounding parentheses to be square brackets, or change the quotes to be backticks. It's just really nice. But definitely takes a little while. So the reason that I started reading about Treesitter is very straightforward. I wanted to be able to get highlighting for KCL. Let me get my screen on. That is the wrong screen. Share screen. There we go. Yeah, that's what I wanted. Cool. So for those who don't yet know what we're doing, Frank and I both work for Zoo, which is a company we're making CAD software. So this is the Zoo modeling app. It's not a very sexy, cool name, but it tells you what it does at least. So we're making a CAD product where you can define your CAD models either visually or with code. So you can use a GUI to start doing commands, like adding new paths and geometry and extruding them, but you can also write code. And we're building really nice integration between the code part and the visual part. So you can see if I mouse over something, if I mouse over the arc here of the cylinder, it shows me where it's being defined. And you can see that both these arcs are being defined by the same little circle function that I defined on the left. And if I look at one particular face of this triangle, I get to see, okay, it's being defined in, function triangle. Nice. If you click into it, it actually shows you the line that it's using to refer to it. So we hope that by having really tight integration between the visuals and the code, it'll make it easier to learn the code and also easier to understand what the code's doing, but then also easier to kind of see exactly what's happening. When you're writing software, you write this code and then you see a bug happening and you have no idea what line of code is actually causing the bug. But if you can literally visualize the exact line of code that is causing a certain thing to be drawn, hopefully it'll make debugging straightforward. But this is our own language that we've been working on. It's called KittyCADlang, KCL for short. And in the editor here, we've got nice little syntax highlighting. That just came built into Code Mirror, which is the component that we're using for this stuff. But oftentimes we're trying to write test files, and if I'm running a test file, or even if I'm running a long KCL file, I personally feel more comfortable writing it in my normal code editors. So if you take a look, we've got Visual Studio Code, and I can get like a KCL file open. And yeah, we get syntax highlighting for it. Let me bump up the font size. You can see, the const is in blue. The numbers are in this weird, I don't know. What color would you call it, Frank? You're a front-end guy.
Name that color, front-end boy. Celery.
Didn't you go to front-end college and took a degree in color names? Yeah, celery. Yeah, let's call it celery. I would have gone with dandelion myself. And that's because we have an extension for KCL. We have a KCL extension for KittyCAD language server. And that is powered by a language server protocol implementation we wrote. Language server, LSPs, it's like a standard for building a server that can respond to queries about your code. So VS Code, when it opens a file, says, give me, let me know like what color every word in this code should be. And then the server we built responds with, this is a bool, so color it whatever color scheme the user chose for bools. This is an integer, so color it, the user's like integer color scheme. This is a keyword, et cetera, et cetera, et cetera. So LSPs are great, but I was surprised because, I screen share a lot with other people in the company, and I see them editing KCL files in VS Code, and I see the colors coming up nicely. And Jess Frizzell, our CEO, she uses Neovim a lot, and so I see the Neovim colors coming up a lot. But I was surprised because if I go to open a KCL file in Helix, let's go to open that sample file again. No colors. So I was a bit bummed out by that. And I started to wonder why. It's because Helix doesn't use the it supports LSPs to do things like show the doc string. And if here, you can see I can pull up the doc string for the start sketch at function. But it uses something called Treesitter to choose syntax highlighting colors. And I'd heard of Treesitter before, but I didn't really know how it worked or anything. But I was like, okay, well, if I want syntax highlighting in my editor of choice, I'm going to have to implement it myself. And I was kind of curious about that because, I've been working with the programming language side of things. I've been working on, the tokenizer and the parser and the interpreter. But there's like this whole ecosystem of things where if you're making a language and people expect, IDE support and docs and examples. And so you want to, I don't know, I was kind of curious about like the full wider ecosystem of programming language stuff. And I thought the LSP was great. And then I realized, okay, well, we should probably make some Treesitter support too. So let's take a look what Treesitter actually is then, hey? So Treesitter is, it's basically a way to define a grammar for your code. So it's a way to define the grammar for your code. So when you have like a file of source code, it's got particular grammatical rules, just like regular spoken languages, like things like a function declaration starts with fn and then an identifier, like a name for the function, and then an equal sign, and then sort of parameter list. So we can take a look. Treesitter is basically a way to define the grammar for a language. And it's kind of like LSPs, like language servers. It's a standard that's agnostic across languages. So this way, in the past, if you had an editor and you had a programming language, you had to kind of implement support for that programming language in that editor specifically. And this meant that if you had M editors, and if you had, I'm trying to make sure I'm fucking centered in this stupid square box. If you had M editors and you had N languages, you had to have this N by N matrix of which ones support which ones. So whenever you have something like that, it's good to have a common standard. So now all the editors can just standardize on having Treesitter support, and all the languages can standardize on having Treesitter support. And then you only have M plus N things to do. So these kind of common standards are really helpful. So we can take a look at an example I found.
I got one question for you.
Yeah.
I know our LSP kind of supports diagnostics, right? Like, is that only in modeling app right now that you get a little like red squiggles? Is that supported by? For Helix? Is that done with Treesitter?
Yeah, look, it's got diagnostic support in the LSP.
Okay. Cool. So it doesn't actually have to like hit the engine or whatever. So it is.
No, it doesn't. It doesn't have to actually generate, or it doesn't have to run code.
Yeah.
I mean, there's going to be some errors that you can't get in this. Like let's say I try to call. Basically, you can get syntax errors here.
Yeah.
You can get parser errors here. But if I try to call, a function that doesn't actually exist, like I don't think it can know about that. Oh, interesting. Maybe it can. I don't know what the unexpected token is.
Yeah, I've seen this. I get the LSP error. I get the diagnostic one.
Oh, wow, it totally can.
Yeah. It just like lands in a weird spot. Maybe that's something we gotta.
Yeah, I mean, we've only got very basic support because we're still a very small company. We're still just trying to get the basics of like the programs can work, and eventually we'll be able to spend more time on things like making the language tooling work nicely. But right now we're mostly focused on getting support within the modeling app itself.
Yeah, and Helix, whenever you open it in Helix, you get the code hints and stuff like that, the other LSP features. Do you get diagnostics? Is it really just the syntax highlighting that's done by Treesitter?
Yeah, it's it's a syntax highlighting. It's also the if you open a real file in Helix, like let's find a Rust file. Yeah, here. So one nice thing that Treesitter powers is that it doesn't just know that I'm hovering over a bool. It knows specifically that that bool is being used as the type of a field in a struct declaration.
This is what you were talking about with semantic tokens.
Yeah, so I can do something like I can hit Alt-O and I can kind of zoom up the AST. So I can expand it to say, not select the whole field, not select the whole struct declaration, all the fields in the struct. Now select the whole struct declaration. Now select the entire, like all the declarations in the file. So this is very cool because let's say when I like change, one little variable being passed as a parameter, and you're like, oh, actually, I want to change the whole like, I don't even want to call this, or I want to change this whole function. It also means you can do things like go to the next function by hitting like square bracket F. You're jumping one function at a time.
And it's not naive, yeah.
Yeah, or you can do square bracket T, or I think there's even, we found something with a lot of args.
That's excellent. Okay, cool. So that makes sense.
Yeah, so you can go to like the next argument, or I don't remember the it shows you here. Go to next up parameter. Okay.
So cool.
Right, so it's going to the parameters of this whole debug function. So yeah, quite cool. So all that stuff is powered by Treesitter.
Great.
And the LSP, I don't think can do that because the LSP tells you, well, maybe it can, but I don't. Well, yeah, I don't think that stuff is possible in the LSP. I think it's powered by Treesitter, and that's what people tend to like, Treesitter. Okay, so shall we start implementing a Treesitter? Let's take a look at an example one first. So there's a grammar for it. So this is the actual Treesitter. This is from the actual Treesitter org on GitHub. And we can take a look at their grammar.js file. So there's some kind of boilerplate stuff we'll get to, but you can see how they define an array. So if you want to parse an array in JavaScript or in JSON, it starts with, let me bump up the size. It starts with a open square bracket, and then something, we'll get to it, and then a closed square bracket. Okay, that makes sense. the insides of it are comma sep, so it's obviously comma separated. So it's saying then you have a comma separated list of values within the array. Yeah, okay, that makes sense. The JS array is limited by square brackets, and then it has a series of values within inside it separated by commas. It's got this this little dollar sign. I'm pretty sure that dollar sign basically means like all the other, it gives you access to all the other Treesitter declarations you've got. So it's calling $_value. And we can see, okay, what is value? We can scroll the way up here, and we can see that defined value is another Treesitter parser. So a JSON value is a choice of one of these different things. It could be an object, an array, a number, etc. Let's take a look at the object. It's very similar to the array. You have a squiggly bracket delimited thing, which has a comma-separated list of pairs inside it. And we can see that the pair is a key, which is a string, then a colon, and then a value, which is that value we saw before. So you get this nice recursive AST where a value can contain other values inside it. And this is all defined inside JavaScript, which is interesting. I wasn't really expecting this. This is some kind of JS module thing, right?
Yeah, that's the classic way of defining module exports. So what that does is it's the same as now with of saying like export default. You're just replacing all of the modules exports with this grammar.
Okay.
Treesitter really uses JS. That's crazy.
So if we look at the website for how to do it, it says you need two things. You need like JS and the C compiler, which are kind of funny to me. They're like opposite ends of the spectrum in some ways.
That's awesome.
But I think you use JS to define your grammar, and then it compiles it with C, or it outputs it as like a little C library. That way every other language can link into it easily.
Wow. They really found like a fun balance of really easy to author language with like high performance there. That makes sense.
Yeah, it is cool. And I like that. I do like that they're using JavaScript for this because, if you were, say, defining this in like YAML doesn't have loops and you can't import something. So if someone, here's a little cursed fact. YAML is actually a superset of JSON. So every valid JSON is valid YAML.
I did not know that.
Yeah, it sucks. But it means that if you wanted to write a YAML treesitter, you could just import the symbols from a JSON treesitter grammar, and then you could add your own new YAML stuff on top of that. So I like that, you could maybe structure this into like smaller files and import them normally, or you could like loop over calling subparsers. It makes it a bit more flexible. And I think if you're just trying to write it in a purely like markup language, like having this be actual code, even though it doesn't really look like code, might be kind of nice. Like you can see that they're using regexes as part of it.
Yeah.
Which is cool. I guess that probably would have some kind of performance implications compared to writing just like logical like sequence, like do these things in a row or do one of those things, because regexes can be, once you start adding regex support, it could get infinitely complex, right? Because the regular expressions take a very long time to run. And I don't know what the JS regex performance is like, but whatever. You can see that they're actually like declaring variables. Yeah, that's another nice thing. I like that you can, numbers are kind of complicated in JSON because they could be just an integer, or they could be a decimal number. They could have an exponent syntax in there.
Mm-hmm.
So it's cool that you can actually define variables, and that means you can break it into small parts, right? You can then say, a decimal integer has an optional negative sign, and then you can refer to small parts, and that way you don't have to write this like huge, complicated, messy tree in line.
Am I wrong in seeing a lot of similarities between this way of building stuff along with Winnow? It reminds me a lot of your talk that we had on Winnow.
Mm-hmm. Yeah.
Where you're making these small parsers and just kind of collecting them up into one.
So this is actually one of my my only real concern with this Treesitter thing is, like, when I first joined the company, Jess was joking about how we always eat during meetings. And we all agreed that was part of Zoo's culture, is we're okay eating on meetings on camera. But I don't know, whatever fucking people out there are going to be like disgusted by this. So but that's just part of the Zoo experience, I guess. Oh, interesting. Alona says that. Okay, it doesn't actually execute anything with JSON, right? Yeah, because we're just using it to define stuff.
That makes sense. Okay.
Yeah, but all this, actually at runtime, any parsing is done in C. Okay, so that makes sense. Thank you.
On the board. It's helpful.
So yeah, as Frank was saying, we've already built a parser for KCL, right? Because when you actually run the modeling app, we have some WebAssembly that breaks it into tokens. So FN would be a token, triangle would be a token, the equal sign would be a token, and then it parses those tokens to get a syntax tree. And then the interpreter kind of starts at the root of that syntax tree and walks down every node and executes it as it goes. So as Frank Bradley points out, I've already written a parser for KCL. And we can actually take a look at it if we go to if we look at here, this is using a library called Winnow. It's a Rust library that I really like, made by Ed Page. Winnow is a fork of Nom, which is like an old favorite classic Rust library. But I think the author is like, the author has other job and he doesn't get paid to work on Nom. So it's been a couple of years since there was much active work on Nom. So Winnow is now being used, I think, in Cargo, because it's used for it's used for TOML and it's used for Cargo. So Winnow is like a very nice little library for writing parsers now. So you can see here, to make a KCL program, got this function that parses a KCL program. We check if it started with a hashbang, shebang, and then parse everything else. So we can take a look for how you parse a value. Yeah, so let me find a... Yeah, here's what I was looking for. This is a function that parses some tokens and outputs a KCL value. You can see, kind of like in the JSON Treesitter one, we've got all the different values that KCL can do. An object with its own function, so look for an open brace, and then there might be some white space you can ignore, and then look for a separated list of 0 or more object properties that is separated by a comma. And then there might be a trailing comma that you can ignore, and some white space, and then there has to be a closed bracket at the end. And then we've parsed out all these little things like the start and the properties and the end, so then we can return the object expression. So I don't want to get too deep into this because we've already put out a bunch of YouTube videos about this stuff. By the way, all the code we're showing is all open source. So it's all on the KittyCAD GitHub.
I'll add a link to that too, but I just love videos.
Thank you, yeah. But yeah, I've already written a parser for this. And so it feels weird to be writing a second parser in Treesitter. But obviously it's because, like Neovim doesn't have any support for Winnow parsers. That would be a crazy thing to build in. But I think my main concern is I don't know how we can kind of keep the two parsers in sync. I think ideally I'd like to have build a way that this Winnow parser could then we could derive a Treesitter parser from that, or vice versa. We could have a Treesitter parser and derive the Winnow parser from that. But you can see the Winnow parser's got a lot of coding logic in it. So, just having two separate parsers for the same language means that if we change language, we'll have to make sure we can keep them both in sync. And I was talking about this with Jess last night, and we were thinking we can probably write unit tests. Like we can have a shared corpus of test files, and we can check that the parsers both give the same results. So we just need to make a way to get the AST from this KittyCAD KCL library and have that kind of be printable as a Treesitter output. And then we can parse everything through Winnow, parse everything through Treesitter, and then make sure the two of them agree. Yeah, basically what Alona is saying in the chat, that we can fuzz both parsers against each other. Alona has been a TA at her university, where she's TAing compiler course. So has a lot more actual experience with compiler stuff than I do. We talked about
That's great.
Yeah. When I was trying to build an actual compiler that outputs, little bytecode VM, she asked me what book I was doing, and I told her I have a copy of Crafting Interpreters. She's like, "Oh, great, that's the book we teach the course from." So,
sweet.
Yeah. So anyway,
I wish I had a course for that. That's excellent.
You and I should go through it together sometime. Okay, so let's then start making a Treesitter grammar. So let's actually, let's close VS Code. So I'm going to get the instructions for Treesitter open as well. Is this going to break if I try to? I don't want to break the screen sharing, but I think this should work. Yeah. Nice. Okay. So cool. Okay. So the Treesitter how to get started page. Build the Treesitter CLI. I already did that. It's just cargo install Treesitter CLI. I've aliased cargo to just C to make it easier to type. So already installed. So we're going to nothing. Okay, so we're going to do what they suggest, which is make a new directory for it, npm init. Yes, version 1. Entry point index.js. Sure, I guess. I don't know. I don't know what an npm module is. Test command. I don't know. Just hit enter. I can choose it.
Alone in the dark. Just alone. A dot in the void just said. And even if you don't make the AST comparable, just checking that both parsers agree if a string is syntactically valid.
Yeah.
A lot of discrepancies for.
Yeah, that'll get a lot of low-hanging fruit. Okay, so that made a package.json file. Sure. npm install save nan. Save your nan. Oh wait, no, I've already got the CLI there, so I don't need to worry about installing it. Okay. So let's create grammar.js. So language name is KCL. Then we can run Treesitter. Let's make sure this is. I kind of thought that would come from cargo. Okay, whatever. But yeah, Treesitter generate. Okay, so I've made a whole bunch of different things. This will generate the C code required to parse this trivial language. Okay, so the example here just parses files that say hello. So we can see if that's actually going to happen. I go hello, and we'll write to example file. And we can call Treesitter parse example file. Okay, so this is the output of Treesitter. This is what a Treesitter AST looks like. It's saying we find one kind of node called source file. That'll be the root of everything. And it goes, I don't know what 0010 mean.
Is it like a node range?
Yeah, I was thinking it might be like offsets in the source code, but it's clearly not. Maybe it's
But it wouldn't be
like it might be lines.
Yeah.
It might be lines of source code.
Mm.
I don't know.
My thought is that it's a range of AST nodes, but I'm not certain.
Yeah, it might be. Let's yeah, we can keep experimenting with it and see. Okay.
Line dash column, if I remember correctly.
Oh yeah. Okay. Cool. So yeah.
Thank you again.
Thank you, Elena. Cool. So let's just make this a Git repo. I think they should already have a git ignore. No. Huh.
To ignore the build.
Well, so I thought they already put. For some reason, I thought they would generate the git ignore from.
None of the steps you did were like, maybe if it was like an npm create, but
we already ran Treesitter generate, so yeah. Anyway, so generated, cargo.toml. I wonder if I was supposed to use lowercase for this, because like cargo uses lowercase for that kind of
for
stuff.
Everything.
And then yeah, we've got
yeah, we might want to only use the uppercase KCL for like the labels. Like
yeah, that's true. Okay, I'm just gonna RMRF everything here and start that one again.
Build it twice.
Cool. Okay. Nice. So let's take a look. Use Treesitter generate subcommand. That will read. We're going to define our grammar for KCL in grammar.js. It'll create the parser as a C file, and then we can just run Treesitter generate again. So this should generate a lot of other stuff too. If we go and look in bindings, I was sure this would generate a git ignore file somewhere, but I don't know, maybe it doesn't. Oh, okay, whatever. I tried doing this before last night to have a run through and it did, but whatever, I don't care. Cool, we can run Treesitter build, and that'll actually compile the source code that Treesitter generate does. It'll make it into a linkable library, so it can be loaded with anything that supports C or WASM. So that's cool. And there's Treesitter test. So currently we don't have any test files, but we can make some. Let's so they've got this nice little DSL for writing tests. This is right. So currently we're just parsing single string hello. So this should parse into being just a source file. And this thing here, these are called S expressions. They're what Lisp uses. It's just a nice way to define a recursive structure. So you can see it's defining a top-level node called source file, which contains another node called function definition, which contains 4 children nodes. So now if we run Treesitter test, this test should pass. Nice. And of course, if we change it to something that shouldn't be accepted by our grammar, then it should fail. Cool. Okay. Very nice. So I think we can start writing like a basic test for some KCL now. Let's take a look at an example KCL file. I guess we can kind of do test-driven development here. So, let width equals 3. That's a typical KCL assignment. So let's have a think. So when you have a KCL source file, and I guess we kind of look at, I can kind of cheat by looking at what my window parser did and copying what it did in a lot of
I don't think that's cheating. I think that's making them match a little bit.
Yes, I guess it's implementing a spec. Oh, we have another Adam from Zoo is joining in. Hello, I've put you on the stage.
Hello.
So let's take a look. So let's just parse one assignment first. Let's just say a source file, and let's take a look at this. These example ones that got here. They were trying to make an example for Go, I believe. Yeah, here's where it explains how the grammars actually work. Writing the grammar. Here we go. The first few rules. So let's say that a file is a repeated list of definitions. And again, this is kind of like writing Winnow in that you've got some like basic parsers, and then you're going to wrap them in little combinators like repeat to make them work. To kind of reuse them and combine them and make a large number of possible parsers, things you can match from a small number of parts.
Like a combinatorial sort of system.
Yeah, exactly. So we've got repeat a definition. So right now, let's just keep definition nice and simple. We'll just say that definition, and sometimes they use underscores. I think that's just to avoid clashing with symbols already defined within Treesitter. So they've got their own already defined thing called.
And that's like a keyword almost, like underscore definition.
Yeah.
Is need to call a definition. Yeah. Okay. And source underscore file is a Treesitter thing that you kind of have to know about. You're filling out this.
So I think definition on its own is already a keyword. It's we're using underscore definition to avoid clashing with that keyword.
Okay.
And then
could we call it source file? We could call source file whatever. That key is not.
I think so, because it shows source file down here. It's the output of our grammar.
Right. Okay. Yeah.
We could call this like KCL program instead.
Mm-hmm. And then okay, great.
So I guess this is actually like the JS syntax for function calls. Like we're saying, like the parser is a function which takes the like overall Treesitter bundle of context and stuff, and we can then use it. But so definition, let's say, is a sequence. It starts with the literal let, and then an identifier, which will have to be something we put in on top of the identifier. And then you're going to be a literal equal sign, and then a KCL value. So if we try to generate it now, it should give us a bunch of errors because we're calling, there's things that aren't defined. Yeah, it gives us undefined symbol identifier. So we can kind of approach this like in small pieces and test each piece as we're writing it. So let's then define what an identifier is. I am going to keep the existing parser open in another tab. I guess this would be in the tokenizer.
Oh, I'll add a link to the Zoom chat.
Workspace, inner word, I think that's what I'm looking for. Yeah, okay. in the tokenizer, we call it just a word, and a variable name is in the. So yeah, the parser takes a sequence of tokens, and the tokenizer takes in like the UTF-8 source code and outputs kind of higher level construct on top called a token, where a token is like a little group of things. So the parser doesn't parse each character one at a time; it parses tokens. Oh, interesting. Okay, sorry. Alona says the underscore isn't a void complex; it marks the node as hidden. So you don't have an expression node. Ah, okay. So that way you don't have an expression node that's just containing an integer literal node. So kind of, Alona, does the underscore kind of let you collapse, like, kind of lets you wrap other node types without having to add them to the tree. That way you don't have like 5 different wrappers around one kind of node thing. Is that correct?
Sounds like it like elides it or something, like makes it transparent.
Well, I guess we can. Okay, yeah. She says, yeah. We'll just experiment by seeing what the output is with it different. Okay. So we made.
She says by default, each grammar rule has a corresponding node kind.
Oh, okay. So yeah. So I assume that the grammar rules and the nodes were like 1-to-1, but I guess you can. It just allows you to distinguish the two of them. That's cool. So we've defined KCL variables. We said they are standard, like, they are like an alphabetical character or an underscore, and then an alphabetical character, underscore, or number afterwards. I thought we let them be like UTF-8.
They can't be Unicode? I didn't know that either.
So I remember now. I started.
Oh no.
We can fix this up. We'll fix this up in the future, because you definitely should be able to use other languages to write your KCL source file. You should be able to call your KCL variables any other non-English language. But for now, we'll just copy that approach too, because it's simpler.
I've been thinking about this for hotkeys because I don't want to like break people's keyboard input, but I didn't even know that the KCL didn't support it anyway. That's fun.
Open an issue. Good first issue for anyone watching the stream.
Internationalization, nice, on our parser.
Well, because when I started prototyping the KCL parser, I definitely used Unicode, because I was like, oh, cool, I can like put in like whatever.
Mandarin, yeah.
So an identifier is a sequence. We said it was going to be. I guess we just use a regex for this. It seems easiest. A to Z or A to Z or an underscore character. Let's see how they put in the. Okay, yeah, that's how they're doing it in here. They just put the regex in straight away. So it's a regex, and then after that, it is going to be repeated of the same regex, A to Z, underscore, or 0 to 9. Okay, the next one we have to define is a value. So there can be different kinds of values you can put in. So for now, let's just keep it simple. We'll just have one kind of value, which will be an integer. $.int. So int, how do you pass an int? It's going to be repeated 0 to 9. Okay, let's see if that is valid. Ah, interesting.
Repeat.
So it doesn't want you to match the empty string, which I guess makes sense, because otherwise you could get, like an infinite tree that's made up of 0 length integers and stuff like that. So let's actually say this is a sequence of at least one number.
Oh, I think you could put that in the regex though, right? You could do the regex.
Yeah, you could put the star
in,
I guess.
0-9, and then plus is one or more of this.
Yeah, we certainly could.
Oh, but this is probably neater to be able to define it that way.
I don't know. I don't have a strong opinion about this. We'll We can come back to it later. If anyone does, you can let me know in the chat. Nice. Okay, that does work now. So let's see what. I'm not exactly sure what this let width equal 3 program should look like. I guess it'll be a
KCL program, right?
Yeah. KCL program.
And then like a new line with a series of definitions.
Yeah, I was just looking for the example here. So yeah, okay, cool. So it'll be so let's not worry about aligning these things yet. Let's keep it simple for now. So it'll then have a definition. That definition will have the let token, it'll have the identifier, and it'll have the value. And the value itself is going to be an integer. So I don't know if this is like value here or if it's integer, but let's see. Unexpected W, unexpected 3. Okay, so we've clearly broken something here. I guess we could start it. Let's start even simpler than this. Let's not worry about the left one equal 3. Let's just try parsing just a single like word. Much add brackets.
I have them.
Okay, so it seems to be it's actually looking for a KCL program there. So let's not do that yet. What was that, Frank?
Got a message in chat. If you use sequence for your lexemes, it means that any implicit rule, usually white space and comments, can fire in between the args to sequence.
Okay, so that's why it's skipping the white space. We don't have to explicitly put in white space there.
That's cool.
Yeah, I like that it strips out comments.
So that is a very useful reason to do the sequence.
Nice. Okay, but we don't actually want that for the integer. We don't want you to put in like spaces between numbers.
Oh right, yeah. So for a word, you wouldn't want that. You do want to use the regex approach.
So let's just do that then. 0 to 9.
Or I think alternatively, /d is all digits.
Yeah. /d, you mean?
Or I always mess up how to say it. I don't know which one's which. Yeah, exactly that one.
Cool. Let's see.
Moving forward along with the text, and a / is leaning back.
Oh, direction of the text is forward. Okay, /.
Oh, you mean you mix up the names, not like
I don't know how to refer to back and /.
Because the forwards is when you're reading left to right. The forwards is going forwards.
I don't know, man. I don't have access.
Okay. So why is this test not running? Not working? It's getting unexpected W. So why does not expected W there? Have I maybe messed up like the? Oh, I think this is a bad regex. Sorry, it's been a while since I wrote regexes, I guess. You have to put like has to be this range of characters, I think. That's. Oh, and then again, gotta. Oh, this shouldn't. Yeah, I did that wrong. Let's match inside these, and then. Okay, let's make this simpler. Let's just make it a single ladder long to see if that to see which part of this is going wrong. Okay, still unexpected. So we've got let, and then let's call an identifier, which is a sequence which matches this regex. Maybe I'm calling the regex wrong. Let me take a look at. Yeah, I don't know what's going on here. I guess we can. It's going to be kind of dumb, but let's just try to avoid the regex for now. Let's just say that an identifier has to be the word width and see if that passes.
Nice, yeah.
Yeah, so it's still unexpected W. So now I'm thinking maybe I'm just going to stop commenting out the tree until I can make it work. Should be a definition. No, the definition has no children. Okay, so now that works, at least. Oh, maybe it's because I wasn't regenerating it before I was testing it. I think that you have to generate it and then put the test in. So I think if you rerun tests, it doesn't regenerate it for you. Let's see if that was the problem.
Is there like a watch command to?
Okay, yeah, that was totally the problem. And yeah, we can definitely we can set up a watch to always be running this stuff. It's like watch fs watch. Oh, that's exactly what I did last night when I was practicing, actually.
Hey.
So now every time we save the grammar, it'll generate. Cool. Okay, now we don't need to worry about generating anymore. Okay, cool. And so yeah, as we were talking about, we weren't sure if it would wrap int or not, but turns out it is. So this value is an int.
And I think this is where if you underscored value,
yeah,
it would
that's exactly what I want to try now.
Yeah,
if we add an underscore to value, that should have generated because we saved it. Let's see. Right, and now it's only accepting just the int here.
That's really cool.
Nice. I have a strong opinion about whether we should be wrapping it in a value or not, but it's cool to know how it works, I guess. Yeah, let's just keep it there for now because we want to learn how this works, not just do it.
I think it makes writing the tests a little bit easier, at least, but I don't know if it like provides any value.
Yeah, that's very true.
Documentation side.
I mean, the tests are kind of documentation for the grammar as well. Okay, so we can parse at least one kind of statement from KCL now. That's cool. So I think at this point, I'll just do a little commit.
I don't think currently the grammar allows for decimal, like floating points. But
yeah, absolutely.
Oh, I mean, my bad. That makes sense.
Oh. Sorry?
Oh, no. Duh. Like, we have an int defined. That would.
Yeah, totally.
Yeah.
I'm just going to push this up. Let's make a repo Treesitter KCL. Guess. No. Should I guess JS? Okay, no. Fuck. I don't know what I was doing there. No. Yes. Good. Oh my god, did I not choose this repo to be it? Okay. Let's add this. KittyCAD / Treesitter KCL. It's the command to push for the first time, whatever.
I think you add the -u. But
Let's see. Yeah, nice. Okay, it's all here. Cool. So can follow along from home now. Okay, so let's make this more realistic. Want to add some more kinds of value. So I think we can probably just copy how like how JSON does their numbers, because I think that is actually, I think currently KittyCADlang numbers are just JSON numbers. We probably want to change it in the future, but for now it's worked out.
that makes sense from all our survey stuff, right? Yeah.
Let's find my number. Next, we can kind of do TDD for now. Let's change this parsing. This should not be. We're going to make a new node called number. And now this should. Oh, nope. Shut up. This should fail. Cool. But if we change the number definition to be the JavaScript one, then it should pause. Yeah, cool. Okay, nice. And yeah, support for JSON style numbers. Okay, what other values do we have in KCL? We have strings. I'm trying to find the. Oh, this is the tokenizer. Cool. So here's a bunch of value types we do support. I definitely want to try get functions in, but yeah, we'll get there. So let's put in strings. String, to parse string, we're going to have, actually, this is going to be a sequence. We're going to have the little quotes delimiting it, and then inside that, I guess you can have like anything. Again, here we can probably copy how JSON does it. Yeah, cool. So in JSON, a string is either an empty string or it is a string with content. And a string with content is at least one string with content. And then, oh, it's a different thing. Different thing here. Okay. Again, I'm just going to copy how JSON uses it. Don't have to think too hard about this part yet. One nice thing is that
match on empty. That's great.
Huh?
And they have the plus in their regex so that it doesn't match on empty. That makes sense.
Oh, cool.
Yeah.
Nice. So let's see if this one works then. We can, I guess, just copy everything. So this should be an identifier and then should be a string. Okay. So this would be a good time to use the learner's trick of the underscores.
Oh, cool.
Wait, no, I thought that, I kind of thought that would.
You put string content.
Yeah, this does have.
You have two definitions. One string content is an underscore, one is.
Okay, yeah. So let's just call this, I don't know, string inner string content. Let's see if this even.
I wonder if this matters for the editor, though. Having a string and then string content.
Oh, yeah, that's a good point because you may have to match around the, like, to treat the quotes as separate character, separate.
Yeah.
Node. Okay, that's a good point.
That's so funny. We did a little foreshadowing with my, like, I love the surround feature.
Yeah. So, okay, good point. And maybe that's why they have the string content here separately. Cool. So, string which contains string content. Okay, nice.
So I bet there's going to be like a function and a function content too.
Yeah.
So braces and stuff.
Yeah. So here we can actually. I was looking at their example in here. They have. Yeah, here's their start of a Go source code parser. So in KCL, you've got we've got so KCL functions. If you're defining a function on the top level, it actually has to start with function. So it's f equals and parameters, and then it's got a function body. I think this is actually a totally valid KCL function.
Yeah,
I don't think we don't require returns, but KCL is like a fully functional language, so we should probably require returns in the parser because it there's no such thing as executing a function for. Well, no, we do execute functions for that side effects because when you execute a function, it can make API calls, but. Yeah, okay. We'll keep it this way for now, but maybe we should redesign that part of the language in the future.
Yeah, that makes sense.
Okay. So we agree this is like a valid function.
Yeah, I believe so. It's not possible to have a KCL function just be an expression like in JavaScript, right? Where you kind of remove the curly braces and you just have an arrow function that has no bounding curly braces.
Yeah, I think that's correct.
I don't think you can do that. Like you couldn't make that function just be x times 2 or whatever.
Oh. Interesting. So this is actually, it does seem to require something in here. Okay, fine.
Wait, do you have to, can you just put like, okay, define a constant above it, like a let above it.
So I think it requires at least something. And
it's just like white space. Yeah. Okay, cool.
Interesting. Yeah, it's still giving unexpected. Obviously, by the way, the errors in the modeling app kind of suck right now, but we do at least have error support, and it's something we definitely like. We built the framework to add better errors in, but it's definitely something I want to sit down and just improve the error messages for a week. Yeah, Esteban, who works on the Rust compiler, has this quote where he's like change how I think about compilers. He's like, people think the compiler is like primarily responsible for generating machine code, and it also has some like error messages stuff. But he thinks of compilers primarily being about giving error messages to invalid code, and also it does some machine code generation at the end. And I think that's actually a really interesting way to think about the compiler. Because yeah, for most users, like just getting the code to work is the main job of the compiler. And then once it's done, you can have more leeway for the performance of the compiler itself. Especially for us, where the compiler is actually making network calls, or the interpreter is making network calls, so we don't really care about how efficient it is because network calls are going to be the biggest part. Okay, so let's say the function has to have something in here. So let's I kind of want to, yeah, okay. So we're going to add a new kind of value, which will be a function declaration. And let's say the function is, it's going to have the parameter list. And then it has the big arrow, and then it has the function body. Oh, it's going to have the dollars here. Okay, and the parameter list is a sequence. We've got the an open paren. We've got closed paren, and in between them we have a comma-separated list of identifiers. So how did they do their comma-separated lists here to do parameters? We can take a look at the JSON. Okay, there's a whole thing called comma-sep. That's cool. So that's built into, yeah, I guess it must just be part like already in scope.
Treesitter thing.
You don't need to import it. Comma-sep of identifier. Okay.
Do you think they've made utility functions for all kinds of separated lists? Or is it just
I don't know. I'd love to be
comma-sep?
able to know where this is getting imported from.
Spooky imports.
Yeah, I don't know. They've always been there.
Yeah.
And there's one set of footprints in the sand, comma separated was carrying them. Okay. And after the parameter list, we have to do the function body. So we've got the open, the close, and then we've got a sequence of statements. I think we call these body items in the main parser. So I'll add that again. Body item. Body item is going to be actually a choice. It can be either an expression, or it can be a definition, or it can be a return statement. So we have to add return statement. Oh, it looks like there's a... Oh, okay, no, the watcher is still running, but it does show us errors now. That's good. So return statement is going to be a sequence. It's going to be the literal token return, and then it's going to be, I guess, any value, right? Any value expression. Okay, still getting an error. Let's see. Comma step is not defined. I thought we got a spooky import. Okay, they did actually make their own function for it. Which I'm shamelessly copying. Huh?
That's a helpful little utility, though. It's very small.
Yeah, and I like that now I can actually see how they built it. You know, I can imagine having, we might want to make like a utility later on for like enclosing, like things are enclosed between parentheses or braces, something like that. Yeah, so I like we can now see how they're defining them. It's interesting to define them as like normal JS functions. It's not like a Treesitter thing. It doesn't take the $ as the first parameter or something like that. I believe in copyright. I respect copyright. Copyright from GitHub into my source code without reading the license. Okay, but it's still giving us an error about something. Unexpected token function. Ah, okay. Well, that's interesting. Oh, it's like outside of the. It's outside of the export, I think. Oh, I think we just didn't define. Yeah, okay. The value is an underscore thing, so we got to put the underscore here. Okay, I think that's working now. So let's see, what should this be? It's got the identifier, and then the value is a function, which contains a parameter list, which is empty. And then it contains a function body, which has, I guess they should all be indented. Contains a function body, which has a return statement. I guess it's got a body item. I'm going to get this so wrong. This is like, if I get
should
this
body item be transparent? Like, should it just contain a bunch of...
Yeah, because I guess like if you're jumping up between, like it always fully contains one kind of statement. There's no like delimiter around it. So yeah, I think that's a good point. It should be an underscore thing. Yeah, we just typed in 4K to go a 4 up. It's a funny shortcut.
Could you done replace symbol with? I don't know if that would work in this instance, but
oh yeah, I totally could, but just seemed more than it was necessary for only 2 instances, so close to each other. Okay, so for the function body, it contains one item, which is a return statement. Oh, Treesitter test -- update. Yeah. I saw. So Alona's pointing out that you can kind of just write the testing and then just grab, like, save its output automatically. But I kind of want to look through the grammar first, like make sure.
Oh, that's really nice, though.
Yeah.
Once
But
you feel confident
with like snapshot testing, basically.
Yeah. Right.
Yeah. And if we get this right in the first time, then we have like huge Twitch stream reactions, like any % of correctly doing a TDD of your fucking Treesitter grammar. I want to clarify that this is my first time streaming, and if I ever become like an obnoxious, if like the stream is ever more personality focused than just writing code, you need to take me out the back and shoot the head with that thing from No Country for Old Men.
I hope this doesn't awaken something in me.
Okay, so we have the function body. which contains some body items, and this one is actually a return statement. The return statement contains a value, which is it's a number. 2 is a number. Yeah, that seems like legit. It passes the sniff test. God damn it. Okay, what do we do wrong now? Oh yeah, we didn't. Okay, so something I said before is that KCL functions start with the declaration function. So we need to have a different kind of definition, which is a function definition. And then this should always be followed, not just by any value, but by a function. Which means this will also be a function definition. Unexpected single quote. I don't see any single quotes in here. Function. Identifier.
You have KCL program is defined as a repetition of definition. Not
yeah. So
I forget
the definition can be, let's call this like a non-function definition, and then we'll have definition be a choice of either function or non-function definition.
And should definition be transparent or appear? Like, do you want it to appear in the graph?
Yeah, okay, that's a really good point. I think we want it to be transparent. So that means we have to update these tests because they are now non-function definition.
Come on.
Okay, so we've still broken the other ones. Let's just see what's going on here. Did I not save this? Why is it saying that it's still... I guess they're not transparent the way that I thought they would be.
But they have been in other instances. Is it possible it's because you're using, like, KCL program is repeat of definitions, so it has to be like appear there? I don't know. I'm very confused by that.
I wonder what happens if we just like totally like do this, like we basically inline this. Apparently get. Oh, I think it's because it was just erroring out. Yeah, because we probably reused. Yep. Okay. Yeah, it was erroring out, and I didn't notice because the same error as before. But the error is that somewhere we are using definition here.
Got it.
Okay. So now, is that still complaining? No. Cool. Okay. So, yay! I do believe in grammars. I do. Okay, cool. So now we can have function definitions. So I want to switch away briefly and take a look at that GitHub repo. I would like at some point to open PRs to this, and there is like a Treesitter GitHub action to test your stuff. So, well, I don't think we're quite ready to open PRs yet. I think we'll do that later. But at some point, we'll return to this and do some like dev tools, DevOps stuff.
Nice.
So let's take a look for what can I open with it?
Oh, I can go to zoo.dev/docs/KCL samples.
Yeah, well, I mean, just take a look at this. We can see. Like, I think we'll get to like Q% and end this. Grammar speedrun Q%. Fucking hell. Okay, so we've got Q. Oh, let's have a test that actually uses parameters firstly. Let's have a parameter X and Y. We don't actually have to use them, but let's make sure that they go away. Let's make sure they actually do succeed. Okay, yeah. We in the parameter list would then have identifiers. Okay, cool. Okay, so yeah, next to get to the, I think having this program run would be a nice point to end this. So next I'm going to do is we have arrays in the language. Currently we store 2D points. It's just arrays of 2 numbers. So let's get this working. I think we can kind of, yeah, I'm not using this very much anymore. So let's again have a test. Let's call this indexing point. Let x equal 0.0. So this should be a function definition. Function definition, which has an identifier, and then, okay, so this will need to have, I think we call these member expressions in the AST. So it'll have a member expression, which will then have like an identifier for the root of it, the point, and it'll have an index, which I guess will just be a number for now. I don't know, this might be wrong, but we'll just see what happens when we get to it. So this is going to be another value type. So it'll be, let's take a look at how the L parser works.
I saw an array type in there.
I think that's for declaring an array. But we want to look at how we parse it. Okay, so yeah, first we parse an identifier, then we look for either, then it could be like either like a dot, like getting like object keys, or it could be the subscript, like getting the component of a vector or something. And then you do that 1 or more times. So you can do that way. You can like mix them. You can have like size.x square bracket 1 dot name square bracket 3. Okay, so let's go back. And we can, like, with all these things, we're not trying to define the entire fully fledged grammar. We're just trying to get enough to get syntax highlighting on a simple file. I mean, we could switch over and look at the installation process now and start and see if we can get actually.
Yeah, honestly, that's probably a good way to wrap up, is to show it working, like highlighting one of these.
Yeah,
a simpler.
Because I feel like I've got the hang of this now. I don't know if like we don't have to go and do the entire thing here. Yeah, that sounds good. Let's try to get this to when we can get syntax highlighting in Helix. Okay, cool. So, well, I do want to get CI set up too. So let's just do that also real quick. I think there is a GitHub action already somewhere for this. Yeah. That's not what I meant. Yeah, I guess we can just look at what other projects do. Okay, yeah, there's Treesitter action already. So let's just copy this, and then in my repo, I will GitHub workflows, and then ci.yaml. Cool. Let's close this. On push to, I don't really care about checking this stuff on push. I just want to check on pull requests. Anything that changes the relevant stuff. I don't really care about concurrency here. I think we can just run on Ubuntu latest. We don't have examples for this stuff, so I just want to run the tests. And then let's call this sort of like examples of files that are and are not valid. Okay, cool. Let's see if this works.
Still working on that GP alias?
Well, P could be pull or push or pick.
It's GL for pull.
No, L is for log.
I read your blog post.
Whoa, okay, let's see. So you think because this PR touches the relevant file, we should also have this run if you modify this file. So let's run .github/workflows/ci.yaml. Yeah, there we go. It's running.
That's slick.
It's a great time for me to finish eating my rice. This video is sponsored by rice, the staple grain.
Everywhere, all the time.
Okay, yeah. So you can see it actually runs the tests we have, and they all passed. So we now have CI, and the CI is green.
Serotonin is up.
Mm-hmm. Nice. Okay. So yeah, okay. So this is going to be where it gets a little interesting. Let's go to that. So, okay, the way that Helix works is that Helix already bundles a bunch of languages. We can now go to, you can add your own languages too. And the way we do that is we're going to go to config/helix/languages. And obviously KCL is a very new language, and I think we're quite big enough that I can like go and start adding pull requests to add support for it and everything. But maybe when we hit like 1.0 of the modeling app, we'll do that. But right now, what I've started is I just put in like the process of changing language support is the same as adding support for a custom language. So you can see I've had to tell it like what files KCL files are and what comments look like. So it knows how to put in comments if you hit command / or if you're Jess, you don't hit command / you just manually type comments everywhere. I hope she hears that when she watches the video.
Shots fired. Catching
she tweeted it out. She tweeted it out. I wasn't going to say anything, and then she just tweeted it out. What block comments look like? Okay, so I have given it a path to my KCL LSP binary, but I think you can see I tried to set up a Treesitter grammar here. But if we have a look at the grammar support, it does say. I think you actually have to use
a URL.
Oh no, there's going to be a path within the grammar directory, which should be built. Some grammar repositories host. No, okay, yeah. So it has to. It has to get it from Git. So let's change that to be Git. Treesitter KCL. And I don't know if we have to give it a revision. But because I might just use main, but it probably should. Otherwise, it doesn't even know what branch to look for, whether it's main or master or something. So let's push up a tag, I guess. Tag vo.o.1.
We can add that to the. Oh, I guess that should be a separate action. That should probably be a separate action in CI, though, right?
Like the tagging stuff?
Yeah, like to make new releases of that.
Oh yeah, I would make a different script or trigger it through a CI or something like that. But yeah, we'll figure that out at some point. Okay. Oh, I didn't know the revision means either commit hash or tag. That's cool. Okay. So have I then told? Okay, so I've told that the KCL language uses the grammar called KCL. So I think having this name here is what it should be looking for. Yeah, the Treesitter grammar to use defaults to the value of name. Oh, okay. So probably don't even need to put it in here because it will default to this value here, which matches this value here. So okay, let's see if this works then. Let's open the tests.
Did you add a wasmlib alias?
What?
Wlib.
Yes, yeah. Wlib is KCL modeling apps.
I gotta do that.
Yeah, I got so fucking sick of typing.
It's so annoying, yeah.
Yeah. Okay, so let's see if I get syntax highlighting. No, but this is also probably like this uses language constructs that we haven't added support for. So let's not do that.
Maybe we can write. Yeah,
exactly. And what was that example that we put in here? We put in like let's just use one of the test files. Something that will work. Sure. I guess the function will be slightly more interesting. Okay, I want to open up the log as well because we're probably going to get some kind of errors. So, yeah. Yeah, interesting. Okay, so let me, okay, I'm going to break these two apart and just full screen my terminal. And this doesn't need to be. So we've got a whole bunch of errors in the log, so I'm going to remove the log. The malformed ANSI is, I think, because the theme I'm using for Helix has some little error in it.
Oh,
So I'm
dang.
just ignoring that in the logs for Helix. So let's see, did it give us any logs?
I got to hop for a meeting, but good luck.
Okay, thanks, Frank. So I didn't get any logs yet, but if we, okay, no, Alto doesn't work, so it doesn't seem like it's using Treesitter properly. I guess we start Googling how to add things to Helix. Because I know that it's yeah, because it's clearly working. Like the LSP is working because you can see it's suggesting stuff in the KCL standard lib. So why is it not getting the grammar part? Very scientific. Oh, I guess we can use the --health command. Let's see. Okay, so it knows about the language server, but it doesn't think we have highlight queries. Okay, so maybe there's something else. Yeah. So I think there's something else you have to do besides just define the grammar. You have to add queries for it. So let me see. Why does it think? Okay, yeah, adding text object queries and then queries, injection queries. Maybe that's what it means. Require an accompanying Treesitter grammar and a text object file. Queries are written in a Lisp dialect. Okay, this seems like something we should have done in the documents here. How to match? Okay, there's probably a thing on, yeah, syntax highlighting. Let's just try to get to that. Treesitter highlight library. Oh, you can do it on the command line. All the files needed. Okay, so we have to actually make files in the repo. Per user configuration. Okay, so let's take a look at how Ruby does it. They have something called files. They have queries. So let's take a look at how they're doing it. Okay, we need to have files files key. So let's add that. grammar.js. So it's told to build the things. And there's no pre-builds, so get rid of that. Cool. And okay, so there's like a Treesitter part here we have to put in. Scope source.ruby. Ruby is the file type. Okay, so putting highlights.scm. Okay, let's just put in that for now. But and instead of finding KCL, the regex will be KCL. I don't actually know what that means, but I'm just going to copy it and hope that it works out. Okay, so now we have to look at how the Ruby repo is putting in this stuff. So they've got a folder called queries and then sort of a bunch of stuff. Okay. So highlights, yeah, highlights.cm. Huh. Well, this is okay. So it's defining like it's like mapping Ruby syntax to, I guess, general purpose types that languages might have. Things like constant or like keywords and stuff like that. Okay, it annotates ranges of source code with logical highlight names like function.method, type.builtin, keyword, etc. Okay. So that makes sense. Like we're defining, this syntax tree node should be highlighted with your theme's highlight color for function.method. Okay, that makes sense. Okay, so we need to put this stuff in, query path examples. Yeah, okay, this is what I was looking for. So here's some source code. Here's the Treesitter syntax tree that it creates. And here's an example query. Okay, so this is like the minimal thing we need to put into that highlights.scm. We're putting in the, certain strings of keywords and certain node types map to certain kind of syntax highlighting types. So that is very helpful. And then maybe they'll start working in Helix too. So let's put this into highlights.scm. That's where it goes, right? Yeah. Obviously, func is not what we have. Function is a keyword. And I think based on the Ruby example, we have this. Yeah, you can put different choices in square brackets. So We're going to have let and function are all keywords, as is return. We have types. Let's put, we have numbers though. Let's do a oh god, what am I doing? Oh no. Oh. Yeah, there we go. Okay, so let's take another look at our grammar.js file, and then let's open up the highlights over here. So we've got what is considered a number? We just have, I think, a number node type, don't we? Yes, and we have. Oh, interesting. Okay, so you can put you can color certain parts of the tree differently. You can actually define mappings, not just from one node, but you can define nested nodes. You could say, if there's an identifier inside a function declaration node, then color this one the function way. Or maybe it's the other way around. I actually know Ruby syntax, so I'm going to just ignore that part. But let's have, I guess there's probably an add string color. Yeah, cool. So let's put that in. We have a node called string. So this should be enough to get us some basic highlights, I think. So, okay, let's double that. Let's open a PR just to make sure. I do kind of want to run this stuff through CI because I genuinely do not know if this is all correct yet. So let's see. Adam, you've done a lot more Neovim than I have. Have you ever had to mess around with Treesitter like this?
I have not, no. I have been lucky enough that it just works, so I don't mess with it.
My hands look like this, so your hands can look like this, etc., etc.
I did notice in your package JSON, it was referring to a tags.scm, and you don't have that file yet, so that might cause an issue. I think in the other one, they were just separated by new lines, not by commas.
Oh, yeah. You're completely right. Yeah. Thank you. This is why I added CI. And you pointed out
in the package JSON, yeah.
Tags.
There's tags. Yeah.
Yeah, thank you.
I don't know if you need that or not. You can just make the file, make it blank too.
Yeah, well, let's see. I'll keep it open. Cool, that's what I wanted to check. Okay. Let's see if that works then. I guess I'll tag again. Let's call this 2. And I will update my, I don't need this anymore. I'll update my Helix to look for tag 2. So now let's do interesting. It still doesn't think we have queries. Did you add queries for the language? Okay. I guess. Okay, yeah, so here we go. Delete add queries, create a new directory for the language with this given path. And it's the first matching query, takes precedence. So I guess this goes in the config file. In the config directory, I guess. So wait, me. Yeah. And I can probably just copy from. Didn't I make a file called highlights.scm? Under queries. So, oh, it's Treesitter /Treesitter KCL /queries. Highlights, let's copy that to runtime, queries, KCL. Yeah, highlight queries now. That's got a checkbox now. Okay. But still no highlights. Let's make sure it's detecting language. Okay, no, it's KCL. Okay, check the line, the logs. Failed to load Treesitter. Okay, so actually I have to install the shared object. So close, I can feel it. I think there should be under the, I don't know how to use the find command. There should be an SO somewhere.
Yeah, find is always hard to remember. I always just
TLDR find.
ChatGPT now. Yeah, TLDR, that would work too.
Dash name start with SO. Oh man. Oh, interesting. I think there's a problem in package.json.
Oh, it's a trailing comma in the list.
Yeah, okay. Do you see what the line is?
The highlights.
Oh, here, yeah. Okay. And I can, merge that in. But for now, we should still be able to build it now. Okay. Stuff works. So how do I get that .so file? I guess that's in the docs that I keep not reading. IND. The build command compiles, okay? What build command? Okay, maybe I should have done the save of I think I might be using an old version of the Treesitter CLI.
Yeah, I just tried the latest version. It definitely has a build command. So
Okay. Well, the lesson here to everyone watching the stream is that programming has a lot of bullshit in it. That's not just writing code, but it's like installing the right versions of the right things in the right places. This water is sponsored by JetBrains and the Rust Rover Rust IDE, which I'm not using. Okay, so now I should be able to call node modules, Treesitter CLI, Treesitter build. Oh, come on, seriously? How does yours have a build function?
yeah, I don't know. Mine definitely has. Mine has like init config, generate build, build wasm. It has a build wasm.
Why? How does it have build wasm but not build? Treesitter CLI, no build.
I also use my OS package for it. So
Maybe if I just brew upgrade Treesitter. I don't know why it needs to install Neovim to install Treesitter, but whatever. It's not my problem. I mean, it is, but whatever. Oh, I was doing, sorry, I was doing -- build. It should be build. Okay, yeah, if I do, it correctly complains there's no -- build found, but whatever. Okay, so we now have probably got some kind of shared object somewhere, I want to say.
dylib. On Mac OS, it'll be dylib, I think.
Huh, okay.
You can probably just copy that to the same place.
Yeah, let's try that, I guess. They're opening this.
Yeah, it is
okay, well,
looking
I
at-
guess I'll copy it into there. Treesitter KCL.dylib. No. Okay, let's look at the logs now. Okay, so it does actually want a .so. Let's take another look at the docs. Okay, either as a shared object. So I guess maybe this is super sketch, but what if I just copied it and renamed it .so, not
Yeah,
.dylib. I wonder if the tail command works here.
Tail -f, yeah.
Yeah. Cool. So it closes. Oh my god! Color!
Yeah.
Yes. Okay, great. I apologize for how much bullshit that was the last 20 minutes. Of, like,
That didn't seem like a lot of bullshit. That seemed like the average amount of bullshit.
yeah, I guess. Okay, I'm really happy to see that happening. Okay,
Yeah, that's cool.
cool. So we built the grammar from scratch for a language. You can see the grammar here. We built a lot of tests for it over here. I don't know why I guess don't know how to actually manage Windows in this Helix thing yet. But yeah, we learned like how, I guess, all the op stuff around Treesitter, like how to make the package.json do what you need it to do, which doesn't really have anything to do with parsing. But the whole point of using Treesitter is because it's like a nice common standard. So you have to know how the standard works so that other tools can find your language properly, as we just demonstrated. And then we also kind of looked at how Helix works, which isn't really relevant to anyone who doesn't use Helix, but it is interesting to see how, like, if you want to write your own software to integrate with Treesitter, if you know how other editors like Helix or Neovim do it, then you can kind of copy what works for them, copy their approach. So yeah, I certainly learned a lot from this, and I hope this was interesting to other people.
Yeah, this was great. I had a good time.
Okay, cool. Thanks for joining me, other Adam.
Thank you.
I think I will end the stream here. Yeah, thanks all. All this code is on GitHub. If you go to, I'll put it on the screen. It is github.com/Treesitter-KCL. Oh god, no, too big. Yeah, go to this URL for all the code. We've been putting other stuff in the chat, and I think you can get a chat replay on YouTube, but whatever, we'll see. Go to zoo.dev to try the modeling app that I was showing off, where you can write KCL code to make 3D models live. Yeah, we're also hiring at the moment, so we're looking for we have 2 open roles. We're looking for like senior front-end dev. So you saw that there's that modeling app. It's actually streaming the app remotely. It's streaming the visuals remotely. We have a cloud engine that's doing all the CAD stuff, and we're streaming the video by WebRTC. So we're looking for a front-end person who can kind of also with like a lot of experience managing back-end connections. So keeping that WebRTC stream up and stable, and keeping the WebSocket channel that we're using to send commands over and responses. So someone who's on the front end, but is kind of in the front end, the back of the front end is how we're calling it. We're also looking for like a lead financial ops engineer, someone to like build out our data and reporting pipelines. So we can do things like, manage the accounting and the taxes and salaries and stuff like that, payroll. So yeah, if you're interested in either of those roles, you can check out the website where we have them, and you can also talk to us on Twitter. We are zoo.dev, or you can @ me, Adam Chow. Cool. See ya.